Imagine standing on the edge of a vast galaxy, gazing out into the night sky. You see the brilliant light of stars, swirling clusters of galaxies, and a network of cosmic wonders. But here's the strange thing. Despite all the brilliance and grandeur you see, something is wrong. The universe doesn't add up. If we look at the visible matter, planets, stars, galaxies, there's not enough mass to account for all the gravity that holds everything together. It's like trying to solve a puzzle but finding that there are missing pieces. This is the central enigma of modern cosmology. It's the mystery of the missing mass, a problem that has puzzled scientists for decades. What is it that we can't see, touch, or even detect directly, but which seems to hold galaxies together like invisible glue? What if the majority of the universe is composed of something we can't even perceive? This is the puzzle of dark matter. We call it dark because it doesn't emit light or any form of radiation that we can detect with our instruments. We only know it's there because of its gravitational effects. But what if this unseen force, this dark matter, is far more than a curiosity? It could be the very key to understanding the structure of the universe itself. The more we delve into this mystery, the more we realize that dark matter is not just a cosmic anomaly, but a critical part of how the universe functions. Now imagine that you are a cosmic detective, tasked with solving a mystery on an unimaginable scale. The clues are everywhere, yet they're incredibly elusive. We know the universe doesn't make sense without dark matter, but it remains hidden from our senses, evading every attempt at direct detection. It's like trying to find the presence of an invisible person in a room, but you only know they are there because the air around them moves. And just like any good detective story, the more we uncover, the deeper the mystery becomes. We know that something is out there, quietly shaping the cosmos, pulling galaxies together with a force so strong that it defies all logic. But what is it? That's the question that drives astronomers and physicists to dig deeper into the very fabric of space itself. In the grand scheme of things, dark matter is a critical missing piece to the puzzle of how the universe works. Yet, even as we uncover more, the nature of dark matter remains elusive. It's one of the greatest unsolved mysteries of our time. It's both unsettling and thrilling to think that something so fundamental to our understanding of reality is hidden from us, just beyond our reach. But what if, by unlocking its secrets, we could finally answer some of the universe's most profound questions? The journey to uncovering dark matter begins with the evidence, the unseen gravity that has left its fingerprints on the universe. The first clue came from the strange behavior of galaxies. When astronomers studied the way galaxies rotate, they made an odd discovery. The outer stars in galaxies were moving too fast. They should have been flying off into space, based on the amount of visible matter present, but they didn't. There wasn't enough visible mass in the galaxies to create the gravity needed to hold them together. Something else, something invisible, had to be exerting additional gravitational pull. This was the first major hint that something unseen was at work in the universe. It was like finding that the objects in a room were moving in ways that couldn't be explained by what was visible. Further evidence came in the form of gravitational lensing. This phenomenon occurs when the light from distant objects, like galaxies or quasars, bends as it passes through the gravitational field of something massive in its path. The mass bends the light, acting as a cosmic magnifying glass. By studying this bending of light, scientists have been able to map the distribution of mass in the universe. What they found was shocking. There was a huge amount of mass in these areas, but it wasn't emitting any light. It couldn't be seen directly, but its presence was undeniable. Dark matter was doing exactly what gravity should do, bending light, pulling galaxies together, and shaping the universe in ways that were impossible to ignore. Gravitational lensing acted as a cosmic magnifying glass, revealing invisible mass in ways we couldn't have imagined before. Then there's the cosmic microwave background radiation, one of the most important discoveries in modern cosmology. This faint, leftover radiation from the Big Bang offers a snapshot of the early universe just moments after it began. By studying this radiation, scientists have been able to infer the distribution of mass throughout the cosmos. The patterns in the cosmic microwave background radiation strongly suggest that dark matter exists, because the cosmic structure we observe today couldn't have formed without it. This radiation acts like a time machine, showing us the early stages of the universe and offering a glimpse into how dark matter played a critical role in shaping the galaxies we see today. These clues are undeniable. Together, they form a compelling case that dark matter is the unseen force that has shaped the universe from its earliest moments, holding galaxies together, influencing the large-scale structure of the cosmos, and playing a role in every major cosmic event we observe. Yet, despite all this evidence, dark matter remains one of the most mysterious and elusive components of the universe. The question then becomes, what exactly is dark matter? After decades of research, scientists have proposed several leading suspects, but none of them have been confirmed. The most widely accepted theory is that dark matter consists of particles known as WIMPs, or weakly interacting massive particles. These particles are hypothesized to have mass, which would explain their gravitational effects, but they interact very weakly with ordinary matter, making them incredibly difficult to detect. WIMPs are a strong candidate because their properties fit many of the observations made by astronomers. They would not interact with light, which would explain why we can't see them, but they would have mass, which would explain the gravitational effects we observe. Another possibility is that dark matter could be made up of axions, hypothetical, very light particles that are also extremely difficult to detect. Axions are a bit different from WIMPs in that they are theorized to have much smaller masses. However, like WIMPs, they interact very weakly with other forms of matter and would not emit or absorb light. This makes axions another plausible candidate for dark matter, but again, we have no direct evidence yet to confirm their existence. Then there are sterile neutrinos, another possible contender. Neutrinos are incredibly tiny particles that barely interact with matter, but sterile neutrinos are theorized to be a heavier, more elusive form. These particles could account for the missing mass in the universe, but like the other candidates, no one has yet been able to detect them directly. While there are many theories, we still haven't identified the true nature of dark matter. Scientists around the world are working tirelessly to detect dark matter particles directly. The hunt for dark matter is one of the most exciting and challenging scientific endeavors of our time. Each theory comes with its own set of challenges and potential breakthroughs, but the elusive nature of dark matter means that the search continues. Despite the various candidates, one thing is clear. We are still in the early stages of understanding dark matter. It's a frontier of science where new technologies and new ideas are constantly reshaping what we know. The fact that we haven't yet detected dark matter directly doesn't mean it isn't there. It means we are still honing our tools, our theories, and our understanding of the universe. The search for dark matter is one of the most exciting endeavors in modern physics. It's a scientific treasure hunt, and the prize is nothing less than a deeper understanding of the universe itself. With each passing year, we inch closer to unlocking the secrets of dark matter, and with that, we move closer to a new era of discovery that could transform our understanding of the cosmos and our place within it. As the search for dark matter continues, scientists have devised a number of groundbreaking experiments to detect its elusive presence. These experiments are incredibly sophisticated, requiring precision that borders on the miraculous. One of the most promising efforts takes place deep underground, where scientists have set up highly sensitive detectors in an effort to shield them from cosmic radiation. Labs like XenonT are using ultra-pure detectors filled with liquid xenon to look for interactions between dark matter particles and regular matter. When a dark matter particle interacts with a xenon atom, it produces a tiny flash of light, which is detected by sensors. These interactions are so rare that the experiment needs to be conducted in nearly perfect isolation, thousands of feet underground, to avoid interference from cosmic rays and other sources of radiation. Other experiments are being conducted in space. Space-based observatories are another crucial tool in the hunt for dark matter. The Alpha Magnetic Spectrometer, AMS-02, located on the International Space Station, is one such experiment. It's searching for high-energy cosmic particles that could be the result of dark matter annihilation. If dark matter particles collide with one another, they might annihilate and produce detectable signals in the form of high-energy particles. Detecting these particles could provide a direct link between dark matter and the observable universe. The level of precision required in these experiments is extraordinary. Scientists must account for the faintest of signals, sometimes requiring years of data collection before any potential evidence can be confidently identified. The pursuit of dark matter detection is a race against time, with researchers around the world competing to make the breakthrough that will reveal this invisible force. Every experiment is a potential step towards solving one of the greatest mysteries in modern science. So, what are the implications of dark matter's discovery? Why is it so crucial for our understanding of the universe? Dark matter is not just a curiosity, it's a key player in the cosmic story. Without it, galaxies would never have formed in the first place. The invisible mass